Solar flares when the sun strikes Earth. The sun, our life-giving star, sustains all life on Earth. But hidden within its brilliance lies a powerful force that can disrupt our modern world: solar flares. These intense bursts of energy are a natural part of the sun's life, yet their effects can ripple across the Earth, impacting satellites, power grids, and even our daily lives. Let's explore the fascinating phenomenon of solar flares and why they matter. Solar flares are sudden, intense bursts of radiation from the sun's surface. They occur when magnetic energy, built up in the sun's atmosphere, is released. Imagine a stretched rubber band snapping. That's how this energy is unleashed. Solar flares emit electromagnetic radiation across the spectrum, from X-rays to visible light. Did you know the largest flares release energy equivalent to billions of nuclear bombs? It's like the sun's temper tantrum. The sun follows an 11-year cycle of activity, alternating between solar minimum and solar maximum. During solar maximum, the sun's surface is alive with sunspots, which are regions of intense magnetic activity. These are the breeding grounds for solar flares. The last solar maximum was in 2014, and the next one is expected around 2025. When the sun is most active, the chances of solar flares and their effects on Earth increase significantly. When a solar flare erupts, it can send streams of charged particles, known as a coronal mass ejection, hurtling toward Earth at speeds of over 1 million miles per hour. These particles take about 1 to 3 days to reach our planet. Luckily, Earth's magnetic field acts as a shield, protecting us from the worst effects. However, this shield isn't foolproof. Satellites are the backbone of modern communication, navigation, and weather monitoring. But solar flares can wreak havoc on them. High-energy particles can damage satellite electronics, disrupt signals, and degrade solar panels. In 2003, a powerful solar storm temporarily knocked out 10% of operational satellites. Imagine losing GPS, TV, and internet services. That's how important satellites are. Solar flares can induce currents in power lines, overloading transformers and causing blackouts. One famous example is the 1989 geomagnetic storm, which left the entire province of Quebec, Canada, without power for 9 hours. With our growing reliance on electricity, such disruptions could have even more severe consequences today, from halting transportation systems to affecting hospitals. Solar flares also pose risks to high-altitude flights and astronauts. Increased radiation from solar storms can expose airline passengers and crew to higher doses of radiation, especially on polar routes. For astronauts, the risks are even greater. On the ISS, they rely on shielding and monitoring to stay safe during solar storms. Did you know that during intense solar activity, astronauts may have to take shelter in specially protected areas of the station? Predicting solar flares is a challenging but vital task. Space weather agencies like NASA and NOAA use satellites such as the Solar Dynamics Observatory to monitor the sun in real time. By studying sunspot activity and magnetic fields, scientists can forecast solar storms and issue warnings. It's like a cosmic weather report, helping us prepare for potential disruptions. We can't stop solar flares, but we can protect ourselves. Engineers design satellites to withstand radiation and include backup systems to prevent failures. Power companies install devices to protect transformers from geomagnetic currents. International cooperation is also key. For example, the Space Weather Prediction Center works with global partners to share data and improve resilience. Despite their potential for disruption, solar flares also create breathtaking phenomena like auroras. These shimmering lights, caused by charged particles interacting with Earth's atmosphere, remind us of the sun's incredible power. The same force that can disrupt our technology also creates beauty that inspires wonder. The sun is both a giver and a taker. Its flares challenge our technology and push us to innovate, ensuring our survival in an interconnected world. By studying and preparing for solar flares, we can turn a cosmic threat into an opportunity to better understand our universe. The question is, are we ready to face the sun's next big flare? With knowledge and teamwork, we can be.